Well, hi, good morning, and thank you so much for joining me here in my shop on August 13th and Sunday, August 13th. A gray and cool day here today. Yesterday, we actually had a tornado warning. Warning means it's very likely, but nothing happened. We had a nice thunderstorm go through, but lots of rain, but nothing serious happened. But tornado warnings, boy, that's something I used to never happened in my life when I was younger. Okay, what are we going to do with this radio? So I've replaced the capacitor that might be putting the output tube at risk whenever the radio is operated. So that's better now. I can operate the radio, not worry so much about, not that I was terribly worried, but think that maybe I'm doing damage to one of the tubes. I'm not really sure what I want to do at this point. Let's assess the radio's operation and maybe look at where its local oscillator is versus the dial pointer, a few other things before I start making more changes to capacitors in the radio. That sounds like fun. Let's turn it on here. Here we go. So there's quite a clear hum in this radio. So I think we know what the next capacitor is going to be. That rattly sound, I guess you could call it, that's not changing. That, I imagine, is also some kind of feedback occurring inside the radio. Motorboating. That sound. It's doing its best. So we're picking up I'm pretty sure this is 590. You can see we're picking it up. It's actually not that far off, is it? 590 would be maybe here. Now, with the sound quality, I guess I could describe that as muffled. It sounds muffled. Okay, well, having looked at the frequency, let's try the short wave band. What's happening there? What was that? Gone now. Oh. Sounds like a capacitor rubbing is what it sounds like. Seems to occur in different places at different times. That's kind of weird. Oh, there's a complete change there. That background noise changed. Is that from a loose tube? Doesn't seem to be. Okay, if we're going to pick something up, it's going to be down here around 9.3. And we're going to put an antenna on it here. As soon as I get the cord out. This is leading to an outdoor antenna, but okay, let's do a couple things. The but is that the antenna is not actually switched on right now. So I use the same antenna, two antennas, to feed three different locations. One of them is my shop here, and I have a switch that selects which location. What's happening back here? So this is going to be the antenna wire. Uh-oh, I don't have my wire strippers. Okay, antenna connection. Now what happened to, as I did that, the tone seemed to change. Okay, it's picking something up. Liable to be up in this higher range here if we're going to hear anything. That's what the antenna switched off. That's what the antenna switched on. Here it's garbled.
This very material is on the news daily, currently, today. The Kurds are probably the descendants from the Assyrians. And the Syrian people, are enemies of Israel. That's not going to happen.
That station is probably 9.33 megahertz. Broadcast out of New York State, a few hundred miles from here. And we're getting up in the higher frequencies. Pretty quiet. So we can hear a background hiss from about here to here. Oh, there goes that funny. There goes the funny. There goes again. What's up? Get the same result here. What's going on? Okay, Well, there was a lot of dirt in the capacitor, and I have tried cleaning it out since the last video, just by brushing it, but I may not have got all of it out, so it may be tumbling around inside here as I tune the radio. Looks pretty clean. Okay, we don't know what all that kind of come and go nonsense was there. So we got a bad hum in the radio. That hum is most certainly coming from this big old filter capacitor here. So I think we're going to change this guy out. That's pretty much a given with a radio of this vintage. This may or may not be the original one that was in here. Pyramid dry cell. This is soldered in. The easiest thing I can do is just cut this band with a pair of cutters. It's usually not very hard metal. Keep the band in here for a reason. This up a little bit here. There. I need some nibblers. There we go. So it's got 4 wires coming out of it. 2 red wires. Do you see a couple of red wires there? These must have been red at one time. A green wire. There's the green one. That's obvious. And the black one is the ground. So a lot of these radios have 3 electrolytic capacitors in them. There's 3 in here. So 2 of them are in the power supply. They're the bigger ones here. 40 microfarad, 160 volt. And then one of them is smaller, 25 microfarads, and of a much lower voltage, 25 volts. That one is the bypass capacitor. It's used as the bypass capacitor on the resistor that's producing the bias on the output tube we were looking at in the last video. So this is the part of this is the capacitor paralleling the 150 ohm resistor. The other 2 are in the power supply. One going here, and look what we have here. Here we have some of that friction tape I was talking about. And for some reason the last guy, even with all this excess wire, decided to connect. Hey, what's he done here? This is a green wire here. Why didn't he hook the green wire to the green wire? Hey, this doesn't look right. This green wire is hooked up to the rectifier tube. No, it isn't. No, it isn't. No, this is the output tube. Okay, well maybe they were... of course, the green wire in the set is a different green wire from the green wire on this capacitor. It doesn't necessarily mean the same thing at all. Often the green wires indicate the signal path, but there's no real standard wire coloring in these radios. Maybe from company to company, but between companies I don't think there was any standards whatsoever. So it's a very straightforward thing. I'm making a bigger deal of it than I need to. This is a little warm. I think it's more than just me holding it. Seems like it's warmer in the middle here. Okay, why he didn't just bring this wire all the way over here and solder it on the terminal is curious to me. I don't know why. So I'm going to cut the wires but leave long tails. Leave long tails. And the black wire might be useful, so I'm going to leave a lot of the black wire in the radio. This last one, I'm going to leave the tail on. So the tails mark where the capacitor came from. If you trim it right off at the terminal, well, if I do, I'll forget pretty quick just which terminal what came from. So we have green wire and the two. Let me lift this one up here. In fact, you know, I'm going to nip out this extra part. Why would he do this? Tip this up. Now that's not the green wire for the green. That's a red wire. Red wire. You know, I can make it into a red wire. Because I feel the urge to drink coffee coming on. I'm going to clip that there. No. Yeah, that's one of the red ones which don't look red. One here, the green one there, and the black one here. Oh, I can't make a mistake, can I? I can't. Coffee time. Okay, so I put in 3 new capacitors here to replace the big guy. And I think they're fairly snug in here. So I have the black on the black wire, and I've got a capacitor on the green, the capacitor on what was red, and then I've installed my own wire here. Good, I think we're ready to go. Because this is the filter capacitor, you need to be very careful. Mistakes are not easily tolerated. Bad stuff can happen, and I'm good at that. I'm good at putting these in backwards. I don't know why, but I'm pretty sure I got it right this time. But in other cases, somehow I managed to get these in reverse. So, I'm sure that's not the case here. Now, I'm going to turn the set on. We're going to want to watch the dim bulbs for sure. In case I have booped up. Let's disconnect the antenna. This is still just a lead coming out of the B- here for testing purposes. Okay. Okay, and the switch is on. Volume's up a little bit. Power on now. Good. Dim bulbs behaving properly. Very good. Just step back a little bit, Jim, just in case it pops. These can go off with quite an explosion. I have an amplifier somewhere I could show you where the capacitor that blew up, you can't even tell it's a capacitor, is over here, and debris from it can be found down in here. Blasted. Kapowie. You wouldn't want that to blast into your eyeball or something of that sort. Okay, I got the radio upside down, so the sound is upside down now. So we still hear a higher level hum in it, but the lower level hum is gone. I could feel it with my finger before. It's gone. So that's kind of interesting in itself, isn't it? Let's tune the radio and see what happens to the no antenna, and we're on shortwave, so that's not going to do anything, I don't think. Kind of a dumb demonstration. Okay, this must be AM. So I think you could definitely say that's an improvement. We're up at the high end of the AM band where there's nothing. I'm sure, yeah. The garbling will be gone, I think. Let's go down to where the station is. Just below here. Hello. There he is. So the garbling in the voice is gone. back to shortwave. You can hear a hum right now, but it's a higher pitch hum. And you can see it gets louder as I turn it up. So that's probably coming from who knows where exactly. That is probably coming from a capacitor in the audio section, I'm going to guess, or a abnormally high resistor. Let's do this next. We'll do a few capacitors in the audio end of the radio, and we can clear those out. And I'm pointing here because the output tube is here. I've already done one that's connected to the output tube. Here's another one that's connected right to the output tube. This guy's tied to the rectifier, but not necessarily involved with the rectifier circuit. This one here. I have another one down here. Ooh, that's really buried in there. Way down there. Ooh. And that's on the volume control. Appears to be connected to the center terminal of the volume control. So this one's probably conveying the volume, and this guy's got trouble. Maybe it would generate that kind of a sound. It's got a long, looks like it has a long lead on it. I can't really see where it's going under all this stuff. Hey, is this thing? Oh. It's not enough deal. Alarm's going. Fingers in the radio with the power still connected and plugged in. Should not turn the radio off by its control. Should always turn it off by the control panel. Hey, new rule. Okay, didn't get a shock. Probably that would have been a bad one. If I got a 120 volt lift, that's not very good. That's bad news. If you think shocks are really not that critical because you're still around, just ask somebody who's no longer around. They got a shock from the same thing you got a shock from. House wiring or something like that. I'm going to cut this guy out here. That's the center terminal of the volume control. Wow. And the other lead is just buried under everything here. So I think I see it coming to here. Okay, we'll push a couple wires around. These wires are fairly stiff and they're quite short, which means you can't really push them around very much. Black wire disappears from view here. Would appear to be going straight to this terminal. Okay, where else could it go? I don't see it anywhere else. I can't move these wires. Let's get the close-up camera going right on that spot there. Oop, tangled up here. There we go. Okay, let me just rotate the camera so it matches my view. Okay, so here's the capacitor. This is the end I've cut free already from the volume control terminals there. I'm trying to move the capacitor, but it's really jammed under all these wires. Okay, so trying to follow the lead coming out of the capacitor. It just disappears under the blue wires. And as far as I know, it never reappears. I think it's on this terminal, right? You know, the one that's the center of the screen there. A little nibbin of wire coming up the back. You see the resistor lead coming over. No, that's not wire. That's There's one down low there sticking off the terminal. I've got to do something with these green wires. Or we can use the schematic. We could use the schematic and determine. It should be pretty easy actually. I should do that because I don't think I can move these green wires here. See them there? Yeah, I'm pretty sure that's it. A little black insulation showing up there. And then it's connected to that terminal. Well, we're going to double check. We'll look at the schematic for the for this capacitor. It's got to be going to that terminal. And what terminal is that? That's terminal number 1, 2. Terminal number 2 on some 2. Oh, but the terminal numbers aren't on the schematic. Terminal number 2. Okay, let's go see the schematic here. So we're coming off the volume control here. This is the capacitor. It's tying to a 47 megohm resistor and onto the grid of the 12 SQ7. Grid of the 12 SQ7. Okay, and again, no numbers written here. Right. Okay, 12 SQ7. SQ7, pin number 2. Pin number 2 is the grid. That makes perfect sense. That the wire will come from the volume control straight to the grid here. And then that resistor we saw is probably the 4.7 megohm resistor. Okay, now it's a matter of getting in there and cutting it. Cutting it and only it. Cut something. Something got cut there. Now can we fish this capacitor out of here? Maybe if I can push this wire this way a little bit. Hold on. Tug him out. Here he is. It came right out. Left behind the little cover. 0.003. Okay, 0.003 has to go in there. Hey, we can test this guy. Let's do that, and then I'll install the new one. What's your guess? Do you think this guy's good or not? What do you think? Okay, watching the opening now on the 50 volt setting. Right open. 150 volt setting. Oh. This is just a 200 volt capacitor, is it? Oh, looks like it says 600 volts. But go back to the 50. So it looks great at 50 volts, but at 150, Okay, so in normal service, this capacitor is sustaining virtually no voltage across it. Hey, let's read its capacitance, but not with this device. I'll use another meter here. Okay, every time I bring this out, it scares all my vintage equipment. So. Oh my God, AI. that's vintage electronic equipment's version of AI is this meter here. This is kind of an AI meter. It's pretty good. Figures out what's hooked up to it and then does a test. So this is saying this is a 0.0035 or 37 capacitor, and the loss is nothing. So this guy's saying he's pretty good. So could this be the cause of, like, what I'm thinking is if this was very high impedance, then it would start acting a little bit like an antenna, an audio antenna, if you like. It would pick up hums and stuff. Probably not the case, though. I don't think this is bad enough for that. So I'm going to put a new one in, and if I can remember where it came from, I better put a clip lead on here before I think I remember now, but even that's questionable. This is why surgeons never take their eyes off the patient where they're working, and the nurse has to hand the tool right into the doctor's hand. So the doctor does not look away, even for a moment. Goodness knows. When you're working on a person, the parts are moving around. They're not, they're not fixed in place like a radio here. It must be just terrifying for a surgeon to lose track of where he is, or look away and look back and go, oh. Yeah, you don't have to do that once or twice. This is just a radio, it doesn't really matter. But if you got a human being in front of you and you're working away with your cutters and your pliers, holy smokes. Okay, time for a coffee break, and then I'll install that capacitor. We'll see if it makes any difference at all, but I kind of doubt it. Okay, got that capacitor installed. Let's just check the connections here. See, I put it back down low, just like the original one, right down against the chassis. I suspect that's not done by accident. Trying to keep the leads as short as possible. There he is down there. Okay, time to try the radio again. Let's flip it over. Because the sound was upside down last time, and I didn't like that. There. You gotta wonder how many people have their speakers installed in their, like the speaker itself installed in the cabinet upside down. They're listening to upside down sound all this time. And they don't even know it. Which I guess means it doesn't even matter. Okay, put that in my box of dead soldiers here. Here we go. Okay, volume is, switch is on. Power's not on though. There we go. Now, let me just hook up the external antenna here. Oh, maybe not. Not while we're doing AM stuff here. Okay, and I think that's AM that way. There we go. Watching the bulbs. Doing the normal thing. Very good. Now I upsized the capacitor that's doing the bypass job on the output tube. Well, that's a little interesting here. We got a little higher voltage here now. There it goes. Okay. Well, it doesn't sound worse, that's for sure. So if you listen to this noise, the noise is continuous right through here. As I tune in the station, you'll hear the noise get quieter. You see the pace of it also changed? The pace of the noise? See there, it's like a motorboat running well. You're shooting across the water. Oh, getting close to the dock. Slow the motor down. Now it's just idling. So, I think this sound is a feedback sound through the AVC system, commonly called motorboating. Here it's... Hey, I fixed it! Just like that. Oh, coming back. Oh, you know what? Okay, so I gotta swallow my words. That ticking sound is probably an interference signal from in my house here, which I experience all the time. have no idea what it is. It sounds like ignition noise from a car engine, but it can't be that. The pace of it, the speed of it changes. It comes and goes. I have no idea what it is. I've not been able to correlate it to anything at all. It's just a mysterious ticking sound. Okay, so I was going to make a great point there, but I won't quite make it. The ticking sound is gone now because... yeah, I should talk less. Let's go for the French station up here. Can you do it? $8.60. Let's try antenna direction. I'm going to tip the antenna roughly 90 degrees. Try again. No, not going to happen. So I use this French station to help judge the quality of radios. And this one's able to pick up the strongest station down here. Not picking up anything in between this location and down below, I don't think. That's interference in my house. Where'd the station go? Hey. Directional antenna. It's that big popping sound. What's that coming from? What would be happening to the radio? I'm just swinging it here. Something wrong with the power cord? Oh! What's happening here? Stand back. So we're still going through the dim bulbs here. If this shorts out... oh my gosh. Okay, we gotta figure that out. That'll be the last thing today. What is going on there? Could this be the same thing I was getting when I was doing all that rough tuning? I was really shaking something in the radio. Something I just did? Could it be this guy hanging out? You know, maybe. It's pretty solid. It's really solid. So wiggling this. So the possibility is this is cord's in good shape. It's almost certainly a replacement cord. I'll have to operate the radio and poke around. So when I'm wiggling the cord, I could be wiggling another part in here, and that could be the real deal. Let's give it a try. And then we'll call it quits for the day. Can I find this part? Where's my stick? Where's the stick? My almighty stick. There it is. At least a stick. Okay, we'll switch it on again. Getting through the dim lights for sure, because we don't know what's going on here. It might be something fairly innocent. Okay. Repeat the chord shake. I don't think this can be doing much down here. I think it's up here. Looks like ticking again. Oh. Oh. Okay. Something happening here. What exactly could be happening there? I'm going to switch cameras and we'll take a closer look. See if we can see something happening. Once again, that ticking is an interference sound, not motor boating. Oh, I gotta get this pretty close. So one end of the capacitor is coming down in here. The other end is up here. There's some frayed wires. I think that's the spot. Let me turn the power off here. Okay, I won't be so scared then to shove this camera into it. Now let me pull the plug out too. Nothing like pulling the plug. Right in here is the sensitive spot. Okay, this is the power cord. Could be as simple as the tube contact is. Well, it looks pretty solid in there, doesn't it? I didn't see anything funny there now, but let me wiggle the capacitor lead. Focus is just a little too. I'm going to come down this way. Well, that looks like a bad solder job. Where am I looking right now? I'm looking. Oh, this is the guy. Right there. So you see, this big wire is the power wire coming in. Have a resistor connection, which doesn't look very good when I'm looking at the solder job there, but you can't see all of it, of course. And then in the back side there's a capacitor, which you can't see from this angle. Let's try up through here. Okay, so this is the capacitor lead here. Well, I don't know. You can see the tube pins sitting, if I can manage to point at it, right here. The contact in there may be poor, and when I flex this terminal, I flex that contact, and that's what's giving us the pop. And, it's the rectifier tube. That's the insides of the rectifier tube there. So, yeah, that could cause a big pop if something's happening there. I'm going to leave it right there. Tomorrow we can pursue this issue, and looks like there's a capacitor. It needs to be changed anyway, right there. And we'll get rid of that guy and carry on. That's it. It's very good. So, sounds better already, but I think we can get it much better yet. I'm pretty sure we can get this thing receiving lots of stations. Okay, well, thanks a lot for watching, and tune in again tomorrow. See ya.